chemistry class. Here we are with the part 2 for chapter number 4, matter. Today we will be discussing the general properties of liquid and the gases. So let us begin here and we'll move to the properties of liquid. As we have already seen or discussed in the previous classes that the arrangement of the molecules in the solid, liquid and the gas is different. As you can see in this diagram also, the molecules in the solid are tightly packed, followed by the liquids where some space is available, and lastly the gases, there the molecules are free to move, maximum space is available in between the molecules. So based on that only the properties will be discussed. So let us read the general properties of liquid. The intermolecular force in the liquid is weaker than in the solids. This force of attraction is weaker in the case of the liquids, and hence the molecules are farther apart. They are away from each other and not tightly held in their positions. What will happen as a result? As a result, these molecules can slip over one another, and finally we can say the liquids can flow. All the liquids can easily flow. Water is a liquid, it can easily flow. That is just because the intermolecular force is weaker as compared to the solids. Let us see the properties now point wise. Because of the weak intermolecular force, we will have the point number 1, that is a liquid has no fixed shape. It easily takes the shape of the container that it is put into. If you take a given quantity, suppose 300 ml of water if you are taking and you are putting in container of different shape, then what will happen? The shape of the water will be the same as the container only. It depends on the shape of the container that the water will occupy or that will attain. So that is what we can say, a liquid has no fixed shape. That is the property number 1. This shape of the liquid will change. Why is it changing? Because the molecules are able to slip over one another, and hence they assume the shapes of the container in which the liquid is poured. Here you can see the photograph. The liquid is present in different containers, and according to the shape of the container only, the liquid also is having a particular container. Although the shape is changing, shape of the liquid is changing according to the container, but the volume of the liquid will not change. Volume means what? It means the quantity, how much water, how much liquid is there, that quantity will not change. If you take 300 ml of water in a small container and put that same water in another container, then the shape will change, but the quantity of water will remain the same. Whatever volume is there in the beginning, it will remain the same. So volume does not change, because the molecules cannot come closer or move away from each other. The distance between the molecule does not change in the liquid, only the shape is changing. Next, now point number 2, a liquid can be compressed only to a small extent. As you can see given diagram, we'll see this diagram here. This liquid molecules are there, and in between different molecule there is available space. This space is available, it is called as intermolecular space. This intermolecular space is available, and when we are putting pressure on the liquid, what will happen? Because of this space that is available, the liquid molecules will start coming close to each other. That is what we can say, the molecules are getting compressed. That is written in the point number 2, a liquid can be compressed, but to a small extent only. That is just because of the intermolecular space, but this space is not very large. If less space is there, so less compression is possible. So molecules can be pushed, but to a limited extent, because the intermolecular space is not very large, it is less there. Point number 3, liquids can flow, that we have already discussed. Because the intermolecular force is weak, molecules can slip one over the other, hence all the liquids easily flow. Example like water can flow from one place to another. Point 4, now a liquid expands or contracts more than a solid. In the case of the liquids, this expansion or contraction is more as compared to the solid. Solid, if you are heating, the molecule will vibrate only. Solid molecules cannot move. But in the liquid, if you are heating it or cooling it, then the molecules will change their position. And we will read here, when the liquid is heated, the molecule move more vigorously and go. They are moving farther from each other and the liquid expands. So on heating, what is happening? Heat is a kind of energy. So when we are heating the liquid, the molecules are getting energy, and due to that energy, they are moving away from each other. And when molecules are moving away from each other, it means that the liquid is expanding. So expansion is in the liquid is greater than the solid. So that is just because, why is it so? Because the molecule in solid cannot leave the position. Solid molecules cannot move, liquid molecules can move. Because the molecules can move in the liquid, that is why only they are having expansion. Liquid molecules are showing the expansion. Liquid can expand. On the other side, now contracting. How the contraction is happening? When the liquid is cooled, the molecules become less energetic. On heating, what happened? Energy increase. And on cooling, opposite will happen. That is, energy will decrease. And when energy will decrease, what will happen? The molecules which are moving here and there, they will not be able to move that much fastly because of less energy, and because of that lack of energy, because of the less energy or shortage of energy, they will come closer and the liquid contracts. What has happened here? We are cooling the liquid. On cooling, energy of the molecule is less and they are coming close to each other. When they are coming close to each other, we say that the liquid has contracted. This contraction also is greater in the case of the solid, not in liquid. Contraction is greater in solid because because here again the same thing, intermolecular space is greater. So more space is there, so again more contraction in the case of the liquid than a solid. So that is the point number 5. Point number 4 we have seen, not 5. We will come to the 5th point now here. Yes, before the 5th point, you see this experiment is given that I skipped here. This experiment will read about the contracting or expanding. So we'll read this activity. Fill a narrow mouth bottle with colored water. हमने एक बॉटल के अंदर colored water fill किया है and fit a transparent straw with the help of sealant and उसके ऊपर एक straw लगाया, एक pipe, और उसको sealant से close कर दिया है. Now place the bottle in the bowl of hot water. हॉट वाटर में रखने से क्या होगा? बॉटल के अंदर का जो कलर्ड वाटर है वो भी हीट हो जाएगा. एंड ऑन हीटिंग व्हाट इज हैपनिंग? एक्सपेंशन होता है. तो वाटर इन द बॉटल विल एक्सपेंड एंड राइज इन द स्ट्रॉ एंड वी कैन इजीली सी दैट कलर्ड वाटर इज कमिंग अपवर्ड्स. व्हेन यू टेक द बाउल आउट ऑफ द हॉट वाटर में से जब बाउल को बाहर निकालेंगे तो वाटर क्या हो जाएगा? कूल हो जाएगा. दोबारा ठंडा होने पे वो क्या हो जाएगा? कॉन्ट्रैक्ट. सो वाटर इनसाइड विल कूल एंड इट विल कॉन्ट्रैक्ट एंड द लेवल ऑफ वाटर इन द स्ट्रॉ विल फॉल. सी दिस एक्टिविटी इज फोटोग्राफ इज गिवन हियर. हमने क्या किया है? बॉटल के अंदर कलर्ड वाटर फिल करके ऊपर एक पाइप लगाई, एक स्ट्रॉ लगाई है और उसको हॉट वाटर पे रख दिया है. बॉटल वी हैव केप्ट इन हॉट वाटर. व्हेन वी हैव केप्ट इट इन हॉट वाटर, हीट एनर्जी हॉट वाटर से बॉटल के अंदर कलर्ड वाटर में जाती है और कलर्ड वाटर भी गर्म हो जाता है. जब कलर्ड वाटर गर्म होगा तो क्या होगा? वो एक्सपेंड हो जाएगा. एक्सपेंड होने से वो ऊपर की तरफ राइज करता है और हम यहाँ पे उस पाइप के अंदर उसे देख सकते हैं. अब उसी वाटर बॉटल को दोबारा से कलर्ड वाटर के बॉटल को हम कंटेनर यानी कि जो बाउल है उससे बाहर रखते हैं. सो ऑन दिस what will happen? It will become cool down and on cooling down again you can see the level of the water. पहले ऊपर था, अब वही लेवल नीचे आ गया है. So that means contraction. On cooling down क्या हो गया है? On cooling down liquid contract. On heating liquid expand and on cooling liquid contract. So this is a small activity to show the same thing. This is written here also. We'll read this one time here. The liquid expand on heating and its level rises and it contract on cooling and its level falls. We'll see the point number 5. All the liquids do not mix with each other. Yes, all the liquids cannot mix. Some liquids can easily mix, like water dissolve with many things, but it is not always true. Some liquids are still there which do not mix with each other, like water can mix with milk, with honey, with alcohol. Easily we can mix. बट वाटर वी कैन नॉट मिक्स विद ऑयल. ऑयल और वाटर आपस में मिक्स नहीं होते हैं. इसीलिए हम पॉइंट 5 क्या लिखा है यहाँ पे, ये हम रीड करेंगे. ऑल लिक्विड्स डू नॉट मिक्स विद ईच अदर. इन दिस केस नाउ द लिक्विड विच मिक्स विद ईच अदर दे आर कॉल्ड मिक्सिबल लिक्विड. यू हैव टू लर्न दिस डेफिनेशन, अंडरलाइन इन योर बुक. मिक्सिबल लिक्विड क्या होते हैं? जो भी लिक्विड आपस में मिक्स हो जाते हैं. एंड सेकेंड डेफिनेशन, द लिक्विड्स विच डू नॉट मिक्स विद ईच अदर, जो आपस में मिक्स नहीं हो पाते उसको क्या बोलते हैं? दे आर कॉल्ड एज इममिसिबल लिक्विड्स. सो दैट इज इममिसिबल लिक्विड. मिसिबल लिक्विड जो आपस में मिक्स हो जाते हैं, जैसे वाटर मिक्सेस विद मिल्क. तो वाटर एंड मिल्क इज व्हाट? दे आर मिसिबल लिक्विड. सो इफ द एग्जांपल is asked, you have to tell both water and milk can mix, water and honey can mix, water and alcohol can mix. These are the examples. In the case of immiscible example क्या बोला जाएगा? Water and oil. वाटर एंड ऑयल कैन नॉट मिक्स विद ईच अदर। यू कैन सी इन दिस फोटोग्राफ नाउ, नीचे क्या है, वाटर है और ऊपर की तरफ क्या है, ऑयल है। दोनों को एक बीकर, एक कंटेनर के अंदर उन्होंने यहाँ पे रखा हुआ है, बट दे आर नॉट एबल टू डिजॉल्व विद ईच अदर। सो दैट इज ऑल अबाउट द प्रॉपर्टीज ऑफ द लिक्विड्स दैट वी हैव डन. We will see the property of gas in the upcoming video.